doing this is, so I did think about talking about some kind of more educational studies sort of things that we're doing, and last talk being about peer instruction. I've just done something really interesting on that. Now I'm thinking, oh, maybe I should have done that, but why didn't I? Because AI and curriculum design is really a lot. I'm not sure everyone necessarily knows, because South Australia is quite a long way away. People know that we're going through a merger of universities. Some people do, but not everyone does. So the University of Adelaide and the University of South Australia are merging. I'm not going to really say anything more about that, except that it is prompting us to think about curriculum design, because when you merge unis, you have new programs, new courses, you're basically redesigning everything. And this is happening in the middle of there being a lot going on with AI. So that's very much on my mind. And also, just most recently, I've had various responsibilities, but I've been much less at the day-to-day coalface of first-year maths teaching. I will be again next semester, coming up soon. But so it's this sort of bigger picture stuff that's really been on my mind recently, which is what I wanted to talk about today. As I say, I don't have lots of answers. I have lots of questions. But what I want to prompt is just the way we think about things. So, work. Yeah. No idea why it's not changing slide.
Oh, it's focused on the wrong thing.
So perhaps let's bring it down. Okay. So firstly, in AI, what do I mean? So already getting to that. I know who else has had to deal with the confusion that they thought AI meant academic integrity. Now it means artificial intelligence, and there's a pretty major overlap between those two things as well. So it's just horribly confusing. Here, I'm definitely meaning artificial intelligence. The other problem there is that, as we probably all know, it's not really artificial intelligence, but it's the term being used, so we'll use it. So, here's an example that's theta-wise. Has anyone seen theta-wise? So I came across this recently because I posted a fairly tricky group theory problem in an assignment. I was curious about whether it could be done, and I did find the question online, and it was on this thing theta-wise, which is a kind of ChatGPT type thing, but the answers were actually findable on Google, and they were wrong. But there was a new one I met, and there's this one, and that one, and that one. Probably a lot of these are just sort of fancy wrappers for ChatGPT. I don't really know, but there's a bunch of these out there. ChatGPT is one that I'm going to use later, but that's the sort of thing. But there's lots of these things, and there's more on the way. Okay, so we're responding to new technology, and the question how we do this. So I've gone right back to 1906. I'm interested in this because, as well as being interested in maths, I'm interested in music. And this is basically composer John Philip Sousa. This is just an excerpt of an entire essay railing against recorded music, because it's going to destroy everything. All right, and so this is the point where, we say, if something new comes along, do you just reject it and say, no, that's not going to work for anything? And there's good examples of this, right? There's things like, they'll always be using horses in war, or no one will need any computers at home. There's things like this. I like this one because, some of the things you talk about, people won't go through the process of acquiring a technique and this sort of thing. I think it's interesting because, I'm not against recorded music. I'm a bit old school and kind of stuck on physical formats, and I have a whole room in my house, which is a testament to my love of recorded music. And so I don't say we should reject recorded music, but the thing I take from this is, though, he's not wrong. I mean, things changed, and there were things that people valued that changed. I mean, you talk about people had instruments in their homes much more often than they learned them, and time spent learning an instrument is a good thing. social things, sharing with other people and doing that, and that was normal, and some of that was lost. And there were a lot more people whose job was to teach music, and there weren't jobs to do that as much in. But also there's no real point fighting it. It was never going to be fought off. So maybe the lesson is that you accept changes, but you also don't just sort of, I mean, you think about what, even if there's things you think you value that are lost by change, you kind of think about how you can move forward and keep things. And recorded music hasn't killed off the playing of music. And there's whole other aspects, right? Because, I mean, who had a piano in their home? Not everyone, right? It wasn't equal. Yeah, probably had to be fairly wealthy. So there's all sorts of things that come out of this. But then on the other hand, so there's people who definitely want to embrace technology. They want us to embrace the latest technology, right? You'll impress people by saying you've embraced this new technology, not by saying that you're skeptical of it. Sometimes it can go wrong. Is a good example. People who jump onto NFTs. More recently, it can go wrong jumping onto the latest car. A lot of stories about that. We all know there's dangers in just embracing something new without caution. So I think there's plenty of reasons for skepticism on AI that go beyond the context of teaching maths, right? And there's wider things that, even if our interest is in teaching maths, there's wider things that we should be aware of as well. So there's a lot of issues about AI as it just stolen people's work. This happens a lot with artwork, for example. There's biases. There's loads written about the sort of biases in it. It's a serious problem. Sometimes there's just low-paid work behind it. There's stuff called AI. It's not always completely done by computer. There's things where there's actually been humans involved in training it, and there's issues with that. There's the environmental impact of the energy use. How much of it is hype? They talk about general intelligence being just around the corner. That's quite different to kind of enhanced predictive text we're looking at now. Don't really know. Funding, that sounds very general. It is very general, but there's a lot of money being poured into this, making things available for free and pushing it. Where is it coming from? Sorry, I keep moving around. It's just what I do.
The second camera decided to latch onto the faces on it.
Okay, I stay away from the screen. Yeah, that's good practice. Yeah, so there's lots of money being poured into it. A lot of venture capital, lots of fossil fuel money is going into AI to diversify. And there's this history of people pouring money into things, and then after a while, all right, everyone's hooked on it, now we want money back. In the future, if we start saying, embrace these tools, will they be available to everyone? Are there equity issues? All sorts of things going on. Again, not maths education, but there's some people generally about tech issues that are really good at skepticism. Corey, Dr. O, Molly White, there's a podcast, Tech Won't Save Us. It's good being aware of a variety of issues around this if it's something that's also involved in your education practice. But what's a good way to face something new? Well, things have changed in the past. So, calculators. I've always dealt with calculators. Most people, that's been a constant. We still probably have differences in stuff like what we allow students to use in exams. I know there's like a standard practice on that with calculators, even though it's a long-established thing, but something. And then there's things like MATLAB and Maple. Again, I mean, as a student, these were already present, and we sort of have some idea about how to use them. So different people use them different amounts. You might get students to do some sort of things. Do you get them to do everything on those? Certainly we don't. All right, but then this is the first one. I just putting up just completely general things as points that mean nothing out of context. But anyway, internet. This is one that actually came out when I was a student here. Not here because this building wasn't here yet, but up the hill when maths was up there. And we had take-home exams. The answers weren't on the internet. In fact, I remember in the cafe outside the Matthews building, first someone first showing me Google. So there's this new search engine, check it out. And a lot of the answers are there. So just the fact the internet's there has changed potentially what we can do. Right before we get to the various tools on it, but then we get to Wolfram Alpha. And so what I'm interested in is, how much did you change first year teaching practice because of Wolfram Alpha? And how quickly did you do so? Does anyone think that they got onto Wolfram Alpha and dealt with it very quickly? Anyone bold enough to claim that? Because I feel that the students knew all about it before I did. Does anyone else feel like that? And so I'd like to learn from what we did in Wolfram Alpha, but I know not everyone did things. I mean, I know, some people have said things that Wolfram Alpha can do and as assignments, and I still do that for reasons. And it's given us a head start, right? There's all these people now dealing with AI doing essay writing, and they've just suddenly been blown away by this. But for us already, particularly at first year level, at higher year level, there were things that Wolfram Alpha wasn't good at. First year level, Wolfram Alpha could do a lot of things. Does anyone have any, how did you deal with Wolfram Alpha? If you did, does anyone got anything they want to suggest? I should probably from microphone, if anyone's got anything to say. Anyone? Do anything?
Just actually one bad. Once the internet came along, I had to stop giving assignments because there was just too much misconduct. And I Google afterwards, find it where people submitted the questions. It's interesting. One question I came up with, and the person said, "I've never seen this question before, but I played around with it and I discovered this." And it's like, yes, this is exactly what I want the students to do, and yet they outsource the problem. And so I had to stop giving assignments, and I hated that because I know I learned most stuff through assignments and more difficult problems to learn on. But now when you can just Google everything, it's a problem.
I've definitely had this trouble. Again, maybe with first year, there's a lot of stuff where you can at least change numbers, change to a different function, and the exact question wasn't there. Now, of course, where we're heading is that's no longer the story, but this is back in when the internet was the problem. For higher level stuff, I found the problem that, there can be a few kind of tractable problems, and every one of them has been posted by someone and answered by, a postgrad somewhere who wants to show off how clever they are, that they can do this undergrad problem on like Stack Exchange. But yeah, that's a problem. But anyone do anything for Wolfram? I mean, do you ignore Wolfram? Does it change what you do?
Well, I think what we do is some things are invigilating. Then some things are just formative, like the lessons. So if they want to ruin the experience for themselves and learn nothing, then they can, but they probably understand that it's formative. And then for assignment, what we do these days is to focus on the writing. And so they can check their own answers. I mean, we allow them to check their own answers in Mobius. So the numerical values they can check. So there's no point in doing it.
Yeah. So this is one. So yeah, and certainly, yeah. So if you have exams where you're not able to use Wolfram Alpha, then that's something, and you sort of have to make it clear to students that you're going to have to do this thing without that tool. And you should also make clear to students why. And there's this thing that will give you the answer. In real life, you can use it. Well, I think we all have answers for that, but students might not know them, so it's important to tell them. Do you ever teach with Wolfram Alpha? Has anyone done that? Yeah.
Long time ago, I gave it up though.
Okay, didn't work.
But I wasn't using it for a major part of the subject, and there was too much of a learning curve for it to be overall a good use of time.
Okay. Yeah, back.
Yeah, I've used it. I frequently show things like Wolfram Alpha in class, and to verify things.
Yeah, so I like this actually. And Zillion found it like in a lecture, and you want to do some calculation, and you bring up Wolfram Alpha, and certainly there was a time when there would just be a definite noticeable reaction from the class, like, he knows about it. Well, he's doing that thing we're not allowed to do. Maybe at school though, it'd be like in our first year class. I had to talk to them about it. I said, I want to calculate this. How about I just do it in Wolfram? And they really like noticeably respond. Like it was weird. Yeah. But I've not done it a lot.
Yeah, that's Sri Lanka or, that's in Sri Lanka or?
Yes, Sri Lanka.
Yeah, and Canada one, it's in the.
Sorry. Okay. Yeah, so interesting. So, but what I get is that, I mean, I don't feel like Wolfram's made a big impact on us. Maybe we can ponder what impact it has made on students. I think it's probably made it. If you use assignments, it's probably made a very big impact on what students do. Oh, wait a minute. Right, so I'll get to AI later. But so already I want to just think about, start thinking through what. So would you get students to factorize this number by hand? Or would you let them use technology? Would anyone make them factorize it by hand? I think I would. Even using technology, then there's a question, right? There might have been a time where they had to learn that maybe you start dividing by primes and you start with the small ones and you get bigger. Now you type factorize 2431 into a something, Wolfram, and it'll tell you. So even the use of technology can be different, right? There's a time where technology might be employing some technique that still involves a bit more interaction, or it might be just the computer gives you the answer. But that one seems pretty non-controversial. So everyone's happy that we don't need to make students do that.
Well, it's divisible by 11, so it's okay.
Yeah. Okay, so what about calculating a 3x3 determinant? So probably everyone teaches algebra. Do you get students to do? Would you get students to do that, say, in an invigilated exam or something, to show that they can do it?
Yeah.
Do people do that? Not everyone. So there's people who don't do it. So
Did you say 3x3 or 2x2?
3x3. Yeah.
If it's one by one?
Well, it will depend on the determinant. Maybe it's very easy if you notice something and so you want to make sure they understand.
Yes, there might be
Also
some.
want to be able to calculate the cross product of two vectors.
So, I mean, so I teach maths for data science, and I'll get them to calculate a 3x3 determinant, and at the same time telling them that they'll and do other things with matrices of that size, but they're probably going to be dealing with very, very large matrices. And so, they might reasonably ask why, Wolfram can do that, ChatGPT can do that. Why get them to do that? And so some people might think, don't get them to do that. Anyone got a good reason why we would do that?
I remember a discussion I had with a student probably 15 years ago, and he was very keen on doing calculations, for example, Gauss-Jordan elimination on a computer, and he finished one. He pressed enter and done the calculation, and then he looked at the result. Then he looked at me. He said, "Well, what do I do with it now?"
Yeah. Thanks, Kaz. ChatGPT 3.5 can't. And so, of course, is jumping ahead a bit, but what we're getting to is, of course, what certain AI tools can't do now might not be relevant for long. But it's interesting. It's terrible. I see people trying to hand in like row reduction, Gauss-Jordan elimination by ChatGPT 3.5, and it is the most incredible nonsense. Not just like bad calculations, but it'll be like, first we'll multiply row 1 by 1. And then it'll say there's a 0 in this entry and there isn't, and yeah, it's terrible. But yeah, so maybe come back to this, but for me, I think that there's an idea of working with something, knowing what it actually is. Rather than just an answer that comes out of a computer. Well, you have to know what it is. But then there's a question, with the determinant, is it enough to know what it does? That it tells you about invertibility, it tells you about existence of solutions, or the fact that it's got, you know, a nice multiplicative property. Are the properties of it enough? I mean, maybe it's easy, maybe some students don't have to learn how to do a 3 by 3. Maybe it depends on the context of the students. A lot of stuff I've been involved in with looking ahead at designing programs are specifically maths programs, like Bachelor of Mathematical Sciences. And so I'm in danger of thinking a lot like that when, of course, a lot of first year teaching is for people who are not future mathematicians. They're from enormous range of areas, and the extent to which they might need to know details, need to know what goes on behind things might vary. Maybe they just need to know how to use things. But I've got a bunch of other examples just to provoke thought, like an integral like this. Do people still do this? Do you still teach students to do the integral of a rational function? I didn't even do this. I know it can be done. I find, I think, I mean, back to being a student, I found something like quite satisfying that you can just sort of work out all the details. It's a bit complicated and you get an answer. Not only can you get an answer, then you can easily check it yourself. But nowadays, I tend to not, would I give that an exam? No, maybe I never will. If there's a method, I tend to sort of have a fairly straightforward one just to prove that they understand the method, but acknowledge that they're not going to be doing this by hand in the future. So it changes how we do things. In the past, we might have had them do a whole bunch of complicated examples to make sure they could do it because you had to work it out by hand. I mean, that time obviously is long gone because, you know, already, you know, this isn't ChatGPT. This is the other tools already do this sort of thing. So it's changed my approach. And in another 3 by 3, you know, determinant, but what about we go to eigenvalues? More and more people are interested in eigenvalues. And more people are asking me to design courses where students learn about eigenvalues and eigenvectors, but they also learn a whole bunch of other stuff in one short course and they don't know much maths to begin with. There's some very difficult wish lists coming from people outside maths who want maths to teach things. There's a lot of interesting linear algebra around data science. And, you know, they want people who go and often do PCA. It's like, you know, are you going to teach eigenvalues and eigenvectors the same way you would for a mathematics major? Well, I can tell you now, I don't. It's just not possible. They're not giving them as much time doing maths as a mathematics major. Okay. And solving this, and so this isn't new AI stuff. This is all questions already out there, and you know, I'm not sure how well we've always dealt with them. Different people dealt with them in different ways based on what we've done before. Okay, there's a link there which you can do if you want. I just out of the way of it. That's a ChatGPT session because I sort of briefly thought about putting ChatGPT on the slides and then remembered that it always gives very long, verbose answers that are never going to fit on slides. And I don't necessarily need you to read through them, but I have put some there and, oops. And the first one is I asked it, why should students learn to calculate 3 by 3 determinant if ChatGPT can do it? So firstly, it did not correct me to say that ChatGPT 3 can't do it. Now this might be ChatGPT 4. And it actually gives a, yeah, pretty good answer that's not too different to what I might give. It carries on a bit too long. I mean, you know, technical, I don't think an argument like, what if you desperately need to calculate a 3 by 3 determinant and you don't have a computer on you? I don't think that's a good argument for students. Like, you know, when you know, solar flares destroy all technology, and you'll be the one with power because you can do 3 by 3 determinants. That's, I don't really go, I don't think that's the way to go. But the other ones are pretty good. Yeah. So there's some, after that, I'll refer to later, there's some specific problems that I put in. So they're just there. You don't really need to look at them now, but they're there that you can look at them if you want to. I need to. Where have I gone?
Control it.
Okay, so, yeah, so why might we ask students to do things that Wolfram can do? It's what we've always done. Now, it's not a very satisfying answer. That's not wrong. I mean, we always built on what we've done before, and that's not a bad thing, right? But you can't just sort of rely on what you've done before without analysing it. We don't really want that. The answer, if someone asks us, hey, in your class, you're saying you need an exam because you want students to do things without Wolfram, you can't say it's what we've always done. Well, I learned and I turned out okay. That might be debatable anyway, but you know, the fact that I'm now allowed to teach this stuff must say something about I've learned it to some standard. Again, it's not completely ridiculous in that we have successfully learned things. That experience is valuable. It tells us something about how you learn things. It doesn't tell us everything. There's other ways of learning things and things change, and that's what this is mostly about. So you got to get out of that mindset. You just fall into it automatically. Okay. More realistically, you want to understand concepts, right? To understand maths, you have to do it. I mean, I mean everyone else, but if I read a maths book, I will have a pen and paper. I'm not reading it, I'm doing it as well. And this is what you do. You have to work through things to understand them. If everything's just a black box that gives you an answer, you don't understand it. So if you need to understand concepts, you need to do things without Wolfram. As a stepping stone to more advanced work, right? The ability to do a lot of first year stuff. On Wolfram, I don't think says we can just skip it. I don't think anyone's saying that. Understanding how things work allows us to do new things. Right? Just getting the answer out of the Wolfram doesn't tell us anything about how it works. I mean, it might explain it. But again, if you haven't done it yourself, you're not going to do anything new. And we don't know exactly what people need. And there's a lot of focus on, you know, what you do, you know, how do these skills map to what you're going to do in the workplace? And as sort of first year maths, you're a long way from the workplace. You're mostly doing things that are leading to further studies. What you're doing in second and third year. And there's something to be said for just a general level of mathematical ability that sets you up to take on a lot of different things. And trying to predict, well, because you can do that with a computer, don't worry about it. I think bypasses those sorts of concerns. So I just, you know, for fun, I'm sure we've all done this, put some assignment questions. These are all assignment questions in some classes this past semester. I put them into ChatGPT to see the latest because, of course, the fact that you put them in last year and something came up doesn't mean anything about what they can do now, right? It's always moving. So I put this one in. This is the sort of thing where, you know, it's a bit of a kind of a test of things. There's a non-numerical thing in there, so it's not just a numerical calculation. You've got to work things out, and it's in those links. It does it completely well, gets the right answer, and gives a great explanation, which we would accept. It's fine. Didn't even fill it up with too much rubbish. I think it's getting better on that. This one, differentiating this thing. And, you know, there's a bit of wording in the question, it's fine. And again, this is something like, you know, that Wolfram could have done as well, but ChatGPT does it and sets it out nicely, explains everything, no problem. This is a less standard one. It's a bit wordy. Basic idea, And this is really an edited version of a larger question, which was to say that you've got, like, we teach them how to find the row space, how to find the column space. And for one of them, you row reduce and take columns from the original matrix, and the other you row reduce and take rows from the reduced matrix. And I always want students to go beyond that just being an algorithm and think about why it's true. So the question come up with is, what if you swap those two ideas? What happens? And so it's pretty simple. They just, you find a counterexample to show that it goes wrong if you get those two things mixed around. So here I asked the row one. And interestingly, when I did this last week, it got it pretty badly wrong. And then when I did it to prepare that session that I linked on the QR code earlier, it got it right. Oops, got backwards. So it's inconsistent. So the first time it came out with a thing saying, yeah, here's a counterexample because 1, 1, 1, and 1, 2, 3 are not linearly independent. That's what I told me. But the next time I did it, it came up with a good counterexample. It came up with, like, I think 1, 2, 3 was the first row, 2, 4, 6 was the second row, and then there was something else in the third row. Worked perfectly well. And so, of course, this is something that Wolfram could not do. This is new to ChatGPT. Right, to take a wordy problem like that and explain it, it's still not perfect at it. You do it. This one, again, this is probably easier for it, but it's, again, a bit wordy. Like, if you were to do this with Wolfram, maybe, I don't know how good Wolfram is this stuff, you maybe have to have some idea about how to contextualize it in maths, what you want to calculate, and do the calculation. But you just put it straight as is into ChatGPT and interprets it. All right. So what we have to deal with is that loads of things we might ask students to do, they put in the computer and get not just an answer. It's not like a calculator, it's going to give them a numerical answer. It will give them a completely explained answer. And if you ask, so how did we get around this in the past? I asked how other people got around Wolfram. I'll tell you, one of the things I did was to ask more for explanation. Don't just calculate something, explain it in words. Doesn't get around ChatGPT once again. Right? You can't get around it that way. So calculate, can formulate word problems. You set a word problem, it can do it. Can explain the answer. So again, sometimes you specifically put in language, you've got to explain the steps, explain why this works. You can do it. So none of these things that I use to get around Wolfram will work anymore. Some less standard questions, but it's changing. In particular, it's been bad at calculations, but it's already, I see, a lot better, and they've been combining it with Wolfram to get good at calculations. So we face the situation where we think that students should do, or maybe we think students should do assignments. They need to do maths to learn it. We ask them to do things, we attach marks to them, which makes it, high stakes that, and there's this computer that will do it. So why, I could do it, then if I get it wrong, I lose marks. Computer do it, I'll get the marks. I mean, maybe I'll read it and understand it anyway, but what's the harm in that? So we have to seriously think about this, right? We can't ignore it. And in particular, there might be students who get the message, yeah, I shouldn't use ChatGPT, and they don't. Lots of other people are using it. It doesn't seem very fair to them. And yeah, it's very interesting that before maybe we had like MATLAB, I just thought that because that's what we've often used, but it could be Maple. So, if we got students to do something with MATLAB, but also we could sort of describe what MATLAB was doing. We can't really describe, you can't describe how ChatGPT got the answer. I mean, you could ask it to use like, I don't know, the Graham-Schmidt process, and it will give you the answer, but it did not use the Graham-Schmidt process. This is a weird thing. And you can ask it. I saw another talk recently that someone pointed out that not in a maths context, in a very general context, that if you can ask ChatGPT how it came up with the answer and it'll give you an explanation, but it's not actually true. Right? It's this weird black box that just optimizes things and whatever. I'm not an expert on AI. Yeah, so that's an interesting difference. Before we had stuff that would calculate based on the stuff that we do. This is a kind of enhanced predictive text. So, that's why I ended up before. I want to get away with, I want to get away with a lot, but I also want to get away from, yeah, but that's wrong on certain things, because that just like changes all the time. And so the question is like, what if it's perfect? How do we teach if it's perfect? And I mean, you can think about that, like if you have students calculate in MATLAB, do you tell them, you know, watch out, it might not give you the right answer? Well, actually, now I think about it, I'm not MATLAB but Python, but I do in certain cases. There's a good case of this. Like inverted matrix. You know, a computer like algorithmic style thing like MATLAB or Python might invert a non-invertible matrix due to a routing error. So there is some already existing cases where you actually have to tell students to be cautious. Don't believe the computer, and you have to understand something more. But generally, for a lot of things, we completely trust. You trust your calculator to give you the right answer, apart from these exceptional cases. All right. And at the moment, we don't really trust ChatGPT, but maybe it could get to that stage. Again, we know fundamentally can't trust it in the same way because it's not implementing an algorithm, but if it's always getting it right, it's always getting it right. So, so what if it is perfect? What happens? And so there's some people who are like, great, this is a great learning tool. It's like just having an expert tutor on hand all the time. Now, we all employ expert tutors. Some of us are expert tutors. We know that expert tutors are a good thing. Do you want an expert tutor on hand 24/7 who will just answer whatever question you ask? Does that help you learn?
Depends on how you use it. Having one available at all times could be good. Then you can scratch your head for several hours before you ask him or them. If you ask after 2 seconds of thinking, then you're not learning.
Yeah. So yeah, sorry for people online. It's like the microphone was off there, but go on. But yeah, the big thing there is it depends how you use it. So and we know this with, you know, when I spent time in a kind of general help area for students come for first year maths help. And, you know, often they'd ask you a question, you give them something to try, you go away, help someone else. And there was some where you come back to them, they haven't done a thing. They're waiting for you to do it. They don't take that step to be independent. And if you're not doing that, you don't learn anything from the expert tutor. And if you're under time pressure and you just want something to hand in on your assignment, you're not too worried about this, are you? You get the answer, you put it in. So, and increasingly, right, there's people designing tools specifically for education. So it's not just like ChatGPT giving an answer. There's people designing AIs to do teaching more like a tutor. But while there's ones that'll just give you the answer there, then that still means, well, a lot for what happens if you're just setting assignments, if you're doing hand in. All right. So the big question is, are there things they don't need to know? Now, not just because of tools like Wolfram and so on, but ChatGPT. Does it change what we need to teach? Does anyone think there are things that we don't need to do?
Well, we used to spend,
Oh, you're first. Yeah, go ahead.
okay. We used to spend a lot of time teaching them integral technique. Maybe we can give them the idea of what these things work, but not spend a lot of time on that.
Yeah. So,
Sorry, the microphone.
oh, is it?
Yeah.
So, depending on where you want.
Okay, up here it says microphone.
This one.
On screen.
This one's on now.
Okay, yeah, no, it was green, I just pressed it again, so. Okay, yeah, so Jonathan, you.
Oh, I was just going to say, I mean, this is a first year in maths
Yeah.
meeting, but I actually wondered about this question from, kindergarten onwards.
Yeah.
Well,
This is important, because we aren't alone in making these choices. These choices might be made for us at school level. These choices also might be made for us, and made, that I was suggesting before, by people in other areas whose students we teach in what they expect.
The same as earlier on, you said, well, do we have to teach them addition anymore? Right, I mean, go back a few years ago when we had calculators in classrooms to start off with, there's a huge cry over it. And we know that because of that, the level of mathematical skills students come in with from high school to university is lowered. But we still use calculators, and think all our work we do is not by hand anymore, right? But we understand what we're doing. That's the difference.
Yeah, so I mean, I think going right back to, like, you wind this back, go right back to something like addition, yeah. And so we think, why should school kids learn addition when there's calculators? Right, it's essentially the same problem as, our problem with, do you have to do an integral technique? Same idea. And for us, it's like, well, do we want to see a student come into first year who can't add some numbers? They're going to have big trouble. Right, and so you need those skills, but on the other hand, is there any point in getting to add just like, 6-digit numbers all day? Probably not. But you better be able to add 1-digit numbers at least.
No, you said 5 times tables.
Yeah.
there's also, sorry.
I mean, an observation is that with every implementation of a new technology, there's a less expectation on what we are able to do. Like, with you look at the kind of calculations students were expected to do prior to calculators, or 80 years ago. That level of calculation would send someone, maybe us as well, into little fits if we're asked to do it now. Whether it be long division, I mean, whatever else. So with every implementation of technology, we're getting people to do less. And so now, right, you're posing the question, the ridiculous question: can we add single-digit numbers? That's more or less where we're stopping people to do, because because we'll use technology to do anything else.
There are other ways of expressing number sets, and so you can have, like, for instance, if you teach two objects of a certain area and put them next to each other, you have some concept of the doubling in area. It doesn't. I'm not convinced that it has to always go back to numerical sort of algorithms.
Yeah, that's a good point. That algorithms can help develop understanding, perhaps, but maybe they're not the only way. Maybe they're not the best way. If your aim has shifted from producing a result with the algorithm to just understanding the concept. So I mean, it's because I haven't worked out, what I think we shouldn't teach anymore, or what things are up.
I think as when I was a student of engineering many years ago, the engineers told us that in time computers will take all our work away. What's happened is the computers have made their work worse. We work harder now, and we require higher quality. I reckon this kind of stuff is so new now, we don't understand what actually will do for us and how it will be used in the future.
Yeah. I mean, the big problem here is the uncertainty. Like I mentioned before, there's like hype about it. We don't know where it's really going. We're kind of in the middle of it. The full impacts aren't really clear. So it makes it very, very difficult if, hypothetically you're given the job of coming up with a new curriculum at this point in time when things are changing. It's maybe quite difficult. And this idea of well, can you just jump forward to more advanced topics? I mean, in some cases, absolutely not. But maybe in other cases, don't need the details. And maybe it again depends on who the students are, what they're trying to do. That, you know, already there are people using computers to answer questions using like PCA who could not calculate an eigenvalue. That's already happening. Right? People already are using, you know, advanced tools to access things, and ChatGPT will open up more tools like that to more people. So there's things, so maybe more the thing is students won't get sent to learn maths from us at all, because the fundamental maths we teach is no longer required to do some of the more advanced things. This is, well, something that to some extent is happening. An experience of engineers being reducing the amount of maths that they expect students to have. Yep.
I mean, I think that you're posing some really interesting questions, and what it brings to my mind is more in a statistics area. So where, you know, first year biologists, say, might ask their students to analyse some data. They've not learnt enough statistics to know when things are appropriate and when things aren't appropriate. They don't understand the underlying concepts. They don't know about assumptions. They can certainly access a package that will do whatever they want it to do, just by, you know, some commands that will say, no way. And so I think, you know, this question about jumping to more advanced topics, or the idea of engineering people saying, we still need, even if a computer can find an eigenvalue and an eigenvector, we still need students, or we still need people to understand what it means to be an eigenvector, what it means to be an eigenvalue. And that's what I think we need to concentrate on teaching when we're teaching these things, rather than the mechanical skills.
So part of, you know, what I'm trying to get here is also that I think that, you know, firstly, this stuff's happening. We have to, you know, appreciate the impact on our assessment is firstly a big thing, on how students learn, and that we certainly should be analysing our own teaching practice and thinking, not just accepting, well, we'll just keep doing the same thing and we'll hope they don't use that thing. We've got to seriously think about it, but also we've got to be in a position to defend what we do. And if we can't, then it shouldn't be what we're doing. That there's going to be, as I say, other stakeholders who we have to defend. This is why we should put this in our course. Or the stuff like, if you want to have invigilated assessment where they can't use certain tools, there's going to be people saying, why do you need that? They can, when they go to the workplace, they'll have that tool. Why are you making them, you know, is it just because you're old fashioned that you're putting them in an exam hall to do this stuff by hand? And so, you know, it's not even enough that we've decided on the answer for ourselves. We need to be able to you know, defend our decisions.
I think COVID has forced our hand with uninvigilated assessment, because now they were using CHEG or something else. So a lot of us, and we've talked about this over the last 4 or 5 years, changed the style of our question to not, here's a 3 by 3 matrix, work out the determinant. The determinant of this matrix is 0. What does that mean? Or here's a row reduced matrix.
Yep.
Hence solve this system of equations. And it was 2 reasons. Much harder to cheat, is the technology, or the expert check could get it wrong. But it also, I think, made us focus more on the underlying concepts of the stuff we're teaching, as opposed to heaps and heaps of algorithms.
Yeah, it's interesting that I think it promotes a good practice that you are testing, understanding concept, not just the procedural aspect. But also I note that they also very much the sort of ways of asking things that also I would do when I had an online exam, and I was also worried about Wolfram. Like, they were allowed to use Wolfram. It was available. There's no point saying you can't use Wolfram. They're allowed to use it. So I wanted to set questions where it wasn't just getting an answer from Wolfram. We had some understanding. So again, that's the sort of thing that worked with Wolfram no longer works. So, maybe I'll get on to assessment.
Got about 5 minutes.
Yeah. So I was just going to point out that for maths majors, it might be different. This is again something I'll come up that you know, I think that there's really good arguments for making them do things. But again, long procedures, I've already kind of thrown those out to an extent where you just do some problems enough to understand it. But there's still, you know, I think a greater idea of understanding. I think that thinking about how AI can be leveraged for mathematical work is something that I'm not seeing a lot of, and I don't know, maybe there's not much, maybe there is, but something we have to seriously consider. We can't ignore this stuff. One thing to think of is that to be authentic in your teaching, you kind of want them to use the tools that people might use. So you might let them calculate things with Maple because that's what a mathematician might do. Are mathematicians using AI? Well, they are, but probably not, well, for certain aspects of their maths work. Right? Certainly, it's got a lot of use as a kind of enhanced Google search. And you can use it in that way. And that's maybe not something that comes up at really first year level, where you're looking at a very maybe defined set of topics. I don't know, but something to consider. But for others using mathematical tools, I've already discussed this a bit. Anyone to come up? Yeah, basically I've said this. I think slides don't matter much. I was hoping not to get through the slides because I want people to say things and answer my questions. So I think I'm happy with that. If there's further discussion about this, I'm interested in what people have to say.
I think Deb had an interesting point there. Sometimes you learn a lot about the structure of something by doing the calculation by hand. I mean, sort of at high school level in grade 11, limit definition of a derivative is very standard. It's, there's dozens of pages on it in Stuart or in any calculus textbook. Yet, it's entirely a procedural question. You could then go, okay, well, the derivative is 0. What does that mean at, these particular points? It also highlights that students may not have any understanding of function notation or function substitution. So when you ask a particular question, you then have the ability to perhaps find out a whole lot of other things that you weren't specifically investigating.
I mean, and this is something that comes up not so much first year level, but yeah, my recent experience is teaching like a level 3 abstract algebra. Always when they get stuck on something, it's like, well, work through an example. That's exactly it. It's the only way they're going to get into it. They're trying to do everything at the abstract level, and sometimes look up even more advanced things than what's in the course. It's like, no, go back, just pick a small group, do this thing, write it down. Yeah, it's the way to answer things.
And maths is a language, and we wouldn't expect to just be able to, give a talk on medicine in Japanese without having some fundamental understanding of the basics of Japanese.
Or does the existence of Google Translate mean you can step straight into an advanced Japanese course?
Clear answer to that is no. So Google Translate's awful.
Maths as a language is a very important point, I think. Yeah, that again, this is something maybe when I was talking about, there's a sort of general fluency with maths that students get. That first year maths often goes beyond just the specific topics to an ability to work with mathematics that will translate to lots of mathematical topics, in a wide variety of areas.
And Charles's point is a really good one about getting that answer and actually working out, okay, what does this answer mean? Interpreting it, whether it's from AI or the Chegg expert or even one of us, here's the answer, what does it mean? I know you've got the answer, great, well done, tick, go on, without having any understanding of what that answer means.
Well, and this comes back to what Charles was talking about, we gave students last year a series, in a tutorial, a series of questions or a series of answers that have been given in tests and exams by other students and some by AI, and asked them to identify which ones are correct and which ones aren't and how to correct them. And if the stuff is printed out, laid out in a printed format, they don't recognise the difference between correct and incorrect, which is a bit of a worry when we're expecting them to learn from reading from a textbook, a properly worked solution. We might as well put an improper solution in there, and going to get as much from it.
I got my students to get into arguments with ChatGPT about some abstract algebra questions. So it's just in this sweet spot where it gives a coherent answer, but it's almost always wrong. And they can actually engage in dialogue, which reveals what they themselves know. And they're essentially doing learning by teaching with it. But it doesn't work at first year level because it usually just gives a correct answer. Or if it's heavily calculational, like Gaussian elimination, it gives rubbish. That sort of approach doesn't help.
Hi, Stuart. It's Deb here.
Hi.
I just wanted to make a comment. So when we say things like, or when people say things to us like, I don't know why we're teaching procedure X because students don't need to know about it, computers can do it for them. It sort of assumes that the only time you'll ever need to use that technique is in this case where the computer can solve it for you. But almost everything you learn in mathematics is applicable somewhere else, and we don't know where that thing might be useful in the future. So, for example, some years ago when I was doing some complicated piece of mathematics and I was trying to find a general form for something, we could put it into the computer for n equals 18, but we wanted to solve this problem for n equals anything, and computers couldn't solve it. It was just too big. We couldn't get the computers to solve